Using the moment distribution method, analyze the frame shown in the figure below and plot the bending moment diagram indicating the critical values. Now this frame for AB, it has the span AB has a length of 7 meters and a moment of inertia of 3I. It has also a point load of 10 kilonewton at a distance of 3 meters from A. Span BC has a length of 2.5 meters and has a UDL of 5 kilonewton meter. For BD, there is no loading. It has a moment of inertia of I, and BD is 3 meters. So let's review the steps that are involved in calculating or in solving this question. So these are the steps. So we look at step number 1, that is calculation of fixed end moments. Then step number 2, calculation of distribution factors. Then step number 3, you carry out the moment distribution. Then number 4, you calculate sagging moments. Then the final step is sketching the bending moment or bending moments diagrams. Now let's start with step number 1, calculation of fixed end moments. Now for span AB, we have 2 fixed end moments, that is AB and BA. We are going to adopt a sign convention, that is clockwise moments are positive and anti-clockwise moments are negative. So I'm assuming at A there's an anti-clockwise fixing moment, and that's why we have negative. For AB we have negative WAB squared divided by L squared. That is the formula if you have a point load. Then for at B, I'm assuming we have clockwise moment, and therefore the formula is WA squared multiplied by B divided by L squared. For A is 3 meters, and of course B is 4 meters. That is 7 minus 3. So if you start with AB, if you substitute the values, you get that is 10 times 3 times 4 squared divided by 7. You get negative 9.796 kilonewton meter. Then for BA, if you say 10 times now 3 squared times 4 divided by 7 squared, you'll get positive 7.347. For BC, again we are using the same sign convention, and clockwise moments are negative and clockwise moments are positive. So for BC, the formula is negative WL squared divided by 12. If you substitute the values, that is 5 times 2.5 squared divided by 12, you get negative 2.604, and CB you get positive 2.604. For CD and DC, there is no loading, so for these two, the fixing moments are both 0. So now we go to step number 2. Step number 2, calculation of distribution factors. Calculation of distribution factors. Now, for if the far end, we only have one joint, that is joint B. If the far end is fixed, then the stiffness factors is 4EI over L. Therefore, for BA, we are going to have 4EI over L. Since we are going to factor out EI, I have not included it in the calculation, so I've just simply said 4 times 3 divided by 7, because the moment of inertia of AB is 3I. So we get 12 over 7. For BC is 3EI over L, because the far end is pinned. So if the far end is pinned, then the stiffness factors rather is 3EI over L. So if you substitute the values, you get 3 times 2, that is the moment of inertia, divided by the length, which is 2.5. And if you work out, you get K is 2.4. Against the far end D, for BD, the D is fixed, so the formula is 4ei over L, so that's 4 times 1 divided by 3, and you get 4 over 3. If you do the summation of the fixed moments, no, not the fixed moments, sorry, the summation of k, you get 5.448. All right, you get 5.448. Now, to get the distribution factor, the formula is k over the summation of k. So for BA, you'll get that it is 12 over 7 divided by 5.448, and you get 0.3147. Again, for BC, it is 2.4 divided by 5.448, and you get 0.4406. And for BD, it is 4 over 3 divided by 5.448, and you get 0.2448. So the distribution factors should always add up to 1. So if you do the summation of all the distribution factors, you should get a value of 1. So now let's go to the next step, and that is the actual now moment distribution. You do the actual moment distribution. So you prepare such a table. Where you have the joint, the member, the distribution factor, and the fixed moment. So starting with the joint, we have joint A, B, C, D, A, B, D, and C. And then you replace the distribution factors. That is 0 for the fixed end. For the pinned is 1, and for the pinned CB is 0. So you replace the distribution factors. You get 0, or rather you input the distribution factors, you get 0, 0.3147, 0.4406, 0.2481, and 0. For the fixed moments, we had calculated earlier. Again, you feed them in the table. Now, before we start distributing, for end C, or for joint C, it is a pin support, so we need to release it. And how do we do that? We release it by applying an equal and opposite moment. That's why I've shown with an arrow. So you put 2.604, and half of that goes to BC. So you release CB, you apply a moment of negative 2.604, and half of that goes to BC, that is negative 1.302. Now the new moments now are computed again, so the new moments will be as shown in the table. Then now you start distributing. The out of balance moment for joint B is 7.347, 7.347 minus 3.906, that is 7.347 minus 3.906, and you get a positive value of 3.441. Now this positive value, so the balancing moment will be negative. So you multiply 3.441 by the distribution of factors. So the first one will be 0.3147 times negative. Now the balancing moment will be negative 3.441. And if you work out that, you will get negative 1.083 for BA. For BC it will be negative 1.516, and BD it will be 0.841. The next thing you do is to do the carryover. So you do the carryover at the fixed end, that is AB. So half of 1.083 goes to end AB, that is 0.541, and half of 848 goes to end dB as negative 0.4211. Finally, now you do the final moments, and the final moments are as shown in the table. That is negative 10.337 for AB. BA is 6.264. BC is negative 5.44422, and BD is 0.8421, and dB is negative 0.4211. The next thing you do is to calculate the surging moments. For AB, the formula is WAB over L. So that will be, excuse me, 10 times 3 times 4 divided by 7, and you get 17.14. Then for BC, it will be 5 times 2.5 squared divided by 8, and you get 3.906. Now finally, the last step now, it will be sketching the bending moment diagram. So the bending moment diagram will be as shown in the diagram. Thanks for watching. Don't forget to like and subscribe.